Good afternoon, everyone. From Delsoft Technologies. Today, I'll be demonstrating NetSim Network Simulator and its various feature and functionality. This tool allows user to design, analyze performance, and validate the networks, and also permit the user to edit the network protocols. So we'll go one by one through slides and show you the features of the software. So first of all, why we use NetSim or any other simulator? So as you know, with the advancement of technology, newer protocols are being drafted very frequently, and it is very difficult to keep abreast with the latest happenings. So moreover, analyzing network behavior using traditional analytic method had become very cumbersome. So it is not easy to manually analyze this network. So considering the fact the large number of parameters are involved, we use these kind of network simulators, which provide an accurate understanding of network behavior and the associated problems and their solutions. Okay. So there is an introduction of NetSim. NetSim is a scientific tool for designing and validating networks and its protocol, and hence it has a lot of relevance in protocol research, development, and defense. In defense, it is used for simulating network warfare. Okay. It has wide range of technologies which is possible to simulate in NetSim. These are Internetworks, which has LAN, WAN, and wireless LAN. Then mobile ad hoc network, MANET. Then WiMAX. Cellular network is also there, which consists of GSM and CD.
Muted. Unmuted.
Cognitive radio, LTE, wireless sensor network, which includes ZigBee. Okay. In NetSim standard version, actually this software comes with two versions. One is academic version and one is standard version. In academic version, you can use it for designing analysis of the networks, but in standard version, you have the facility to edit those protocols. So in standard version, users are provided with C source code for network protocols, which are being implemented based on IEEE and IETF standards. The purpose of this C source code is to enable users to edit the standard protocol code according to their own requirement. And they can link it with NetSim and analyze the performance of their newly designed protocol. Okay. Now NetSim has some set of customer segments like enterprises, defense, R&D labs, academic. In enterprise, they use it for network design, network validation. In defense, they use it for network-centric warfares. In R&D labs, they use it for protocol development and new technology testing. In academics, it is being used in network labs for BTech and BS. Then it is used for advanced network lab for MTech and MS, and some PhD thesis work projects. Now this is the architecture of NetSim. Okay, this will give you a holistic view of NetSim, where users will design the network and configure it in GUI interface, which will further simulated by NetSim engine, and thereby it provide multiple metrics regarding their performance of the simulated network. So user is not required to write any script or code while designing and configuring the network scenario. Okay, so this is one of the most striking feature of NetSim, which is the NetSim engine itself. As you can see, it is utilizing a virtual network stack, which actually mimics the real world TCP/IP stack, and hence it makes it very easy for any user to edit the protocol, and it will give you fairly accurate results. Okay. Now the components. So NetSim is divided into 9 components. First of all, component 1, which is Internetworks, which includes Ethernet, fast and gigabit, ARP, wireless LAN, 802.11 ABGN standards, then propagation, free space, log normal shadowing, then firewalls, routing of RIP and OSPF, queuing, And then some common module applications are there where you can generate uh, various type of network traffic on any node. So it has a traffic generator. So it can create voice, video, FTP, database, HTTP, these kind of packets on any node. Okay. Then it has a command line interface also. Then some metrics engine which creates packet and event trace. Then packet animator. So these are some common features which is available uh, in the component one. And these are the IEEE standards. These components are based on these standards only. Then component 2 is there. Component 2 has legacy network, that is Aloha, pure and slotted, CSMA CD, token ring, token bus, ATM, frame relay, MPLS. Then component 3 has BGP network, border gateway protocol. Then component 4 has advanced wireless networks, that is MANET, which includes DSR, AODV, OLSR, ZRP protocols, and WiMAX. Okay. And component 5 has cellular network, which includes GSM and CDMA both. Then component 6, it is wireless sensor network and personal area network. So for using component 6, component 4 is required. Then WSN and PAN network has their agent model and battery model with ZigBee. Then component 7 has cognitive area network, that is WRAN, wireless radio area network. Then component 8 is LTE, long term evolution. Then component 9 is military radio network, that is also require component 4. Okay, so these are the components. Now what's new in V8? So currently it is version 8 of NetSim. Now it is version 9 actually, but it is not at launch till now. So currently we are using 8.3 version. So these are some features that has been upgraded. One is LTE. LTE has OFDMA for downlink and SCFDMA for uplink, then MIMO for enhanced throughput. These are some features that has been upgraded. And dynamic metrics, it gives you a link throughput graph, application throughput graph. Then UI property view. In this you can edit some of the properties of the nodes and devices in XML. And BGP and cellular with stack. Then some new application models have been upgraded, that is peer-to-peer, email, and HTTP. Okay. Then NetSim hands-on. So we'll divide these NetSim hands-on practice in two parts. One is model, simulate, analyze the variety of network, and one is write your own code and link it to NetSim. So when we work on NetSim, we model, simulate, and analyze the variety of networks. Then we have to change the protocol. We go to the coding section and change this coding. So first of all, we go to the part 1, that is design the network, where you can drag and drop your nodes and links and create your own network. Then configure the network, where you can set the properties of the network by right clicking on that node and set it through properties. There are some default properties also and some changeable property that can be changed according to your requirement. Then model traffic. You can model the traffic on any node by selecting the node, like various kind of traffic like email, HTTP, peer-to-peer, various kind of traffic you can generate. Then simulate the network. After modeling the traffic, you can simulate the network and see the result. So this is one summary of this modeling and simulation. Here you can see in the screenshot there is a small network created, and there is a property view of the application where you can change the application type to custom, CVR, email, HTTP, and set the source and destination ID, their timing, packet size, inter arrival time, Okay. So there are two ways of running the NetSim. One is CLI command line interface, or one is XML based config files. So when you work in GUI, it will create XML based config files, which we prefer to use it because it is very quicker for understanding, better presentation, and it has automatic format verification. Now performance metrics. In performance, after the simulation, the performance metrics uh, is created, in which there are several matrices given. I'll show you. After that, packet animator runs your packet animation, where you can see packets moving from one node to another. Now this performance metrics, here you can see in performance metrics there are set of metrics given here: network metrics, application, link, protocol, device. So in network metrics, it allows user to view the values of the metrics obtained based on the overall network. Okay, so overall network performance you can see from there. Then in application metrics, it displays the various metrics based on the application running in the network scenario, like throughput, delay, and many more. Then link metrics. Link metrics displays the value of the metrics related to each link, like packet transmitted, packet errored, and packet collided. Okay. And protocol metrics, it displays the protocol based metrics which are being implemented in network scenario. Okay. Then device metrics, it displays the device related metrics like ARP table, IP forwarding tables. So this will give you the summary of your analysis about your network. Now packet animator. Here you can see in the screenshot, packets are moving from one node to another. It will run after the simulation, and you can change the animation speed from here. You can change the color variation of the control packets, data packet, and error packets. Okay, animation speed can be varied from here. Now, as I've told you that the software has two versions, one is academic and one is standard. So whatever I shown you, these features are available in both the versions, academic and standard. Now some of the exclusive feature which are available in standard version is given here, like traces. Traces are of two types here. One is packet trace and one is event trace. Okay. So packet trace give you a set of chosen parameter for every packet as it flows through the network, such as arrival times, queuing times, departure times, payload, overhead, errors, collision, etc. You can see in the screenshot, the blue screenshot is of packet trace and this black screenshot is of event trace. And this event trace, it records every single event along with associated information such as timestamp, event ID, event type, device ID, protocol name, etc. So these are the two traces available in the standard version for the better understanding of traces, these packets and the events performing in the network. Now dynamic metrics. Dynamic metrics, it allows user to monitor the value of parameter over simulation timing. So this is very essential for researcher to understand the behavior of a network at any instant of simulation timing. So in link throughput, application throughput, and TCP congestion graph, these can be generated and plotted during the simulation or after the simulation. We prefer it after the simulation because during the simulation our simulation will get affected and it will delay the simulation. Now Wireshark. Wireshark, as you know, is a free and open source packet analyzer which is being used for network troubleshooting, analysis, software, and communication protocol development. In NetSim, instead of performing some mathematical calculation and providing the result to the user, it actually generates the packets and transmit it within the simulated network. Hence, it can be used inside NetSim to capture these real-time packets at multiple node location and perform further analysis. Here you can see in the screenshot also. This is the real-time packet capturing given in the screenshot, and some graphs also, RTT graph and window scaling graph. Okay. So you can enable Wireshark on any node during the property wizard. You can set this Wireshark. Now we have done the part 1. Now we'll go to the part 2, where is development platform, which is available in standard version only. Here you can see in the screenshot, one is for programming window, one is for GUI window. So in the programming window, we will have the Visual Studio, and we'll have program of any protocol. So we have just show you that we have edited one of the protocol and set the printf statement there for hello world. So when we integrate it with GUI, it will first show you the hello world printed over the simulation, then it will run the simulation after. Okay. These protocol codes are available in the C installation directory of the NetSim, that is C program files and NetSim standard. Now NetSim has provided a variety of APIs for protocol developers. These are available for developing, that is packet.h, stack.h, list.h. These are some of the APIs available. And these are some of the customer base for NetSim in different segments like defense, space, industry, international, India in education. Now we'll start with the software. Can show you one of the experiment to how we can so this is your first environment of the window. For doing any simulation, you have to go for simulation, new, Internetworks, legacy network. In Internetworks, you can design wireless and wired network. In legacy network, you can design pure Aloha, slotted, traditional Ethernet, token bus, token ring, ATM. This kind of traffic, this kind of any experiment you can design. Advanced wireless network, MANET and WiMAX, and BGP networks, cellular networks, GSM and CDMA, and wireless sensor network, and personal area network, that is ZigBee, and cognitive area network and LTE network. So we'll show you Internetworks, how we can design this and analyze the network. This is the software environment where you can drag and drop these nodes and design the network. Here you can see these nodes are available, and some of the nodes are disabled as they does not belong to these Internetworks. These are for cellular networking, wireless sensor. So first of all, we have to drop down some nodes, like it has wired and wireless node. These nodes are disabled. So first we have to create wired node. Take some switch, router, then one access point for joining some wireless node. Now we have to connect these devices through link. So first wired link, we have to connect these two wired nodes. Then for wireless node, we have to connect it through wireless link. Okay. Now we have connected these nodes. Now we have to set the properties for this. We just right click on properties of this node. Okay, so we can see the property of this node. One is global property, that is for device name, device type, its location, and Wireshark. As I've told you, you can enable Wireshark on any node to see the real-time packet capturing. So we just enable one of the node. You click on online, and the Wireshark is enabled now. So when we run the simulation, it will run during the simulation and capture the real-time packets. So application layer is different. Transport layer. In transport layer, you can see TCP, UDP protocols are being implemented. There's values you can change, congestion control algos you can change, old Teo, Reno, new Reno, and there is one good thing there. There is an information tab given here. If you click on information tab, it will give you the information of these properties. So if anyone doesn't know this information about this tabs, you can click and see their definitions. Okay, the network layer and interface Ethernet. Here also network layer, data link layer, physical layer. Here you can change the IP addresses, subnet mask, default gateway, and these are all features. You can accept it. We have enabled the Wireshark here, so when we run the simulation, the Wireshark will run. So like nodes, you can edit the link also. You click on properties, it will give you link type, link medium, link mode, and maximum uplink and downlink speed, uplink and downlink BER. You can implement some errors, or you can put it to no error. Then properties of switches. These are the default properties, and some changeable property also. Switching mode you can change. Store and forward, cut through or fragment free. Speed you can change. Okay. Switch priority you can change. Buffer size you can change. So these are the properties given for different interface 1, 2, 3. You can accept it for default. Then some router properties. Router scheduling type you can define, buffer size define, then IP addresses and data link and physical layer are being default. Then this is for interface 2. Then network layer. In network layer you can set the firewall. You can set the firewall, and if you want to disable any node, you can disable their path. Okay, so click on accept. Now this is the property for access point. Here you can click on interface of wireless and interface of Ethernet. So this is the interface for wireless. That is, you can enable these standards, then change the buffer size, the standards, transmitting power, standard channels you can define. Then set of properties are given that may affect your network. You can change from here. So set it for accept. Then some wireless properties. So link type, link medium, the channel characteristic. This is for fading and shadowing, fading only, line of sight, or no path loss. So if we click on no path loss, you can accept it. Okay, so we have set the properties for this network. Now we'll send some traffic on this node, like node 1. We have to drop down this application, and when we right click on this, we'll get this application property window. Here you can define application type of CBR, custom, email, HTTP. This kind of application you can define. If you click on custom, you have to set the source ID and destination ID. Like I set 126. Okay. Then source to destination, there will show it will show a line. Then you can change the packet size. Either its distribution is constant, or you can change it to exponential, its value in bytes, and inter-arrival time, its distribution, either it is constant or exponential, or you can change the value of the timing, the inter-arrival. So you can set it for accept. If you want to add some more application, you can click on add and add some more application to different source and destination IDs and different application type. So click on accept. Here you can see there is a line which shows that source 1 to destination 6 has an application of custom type. So it will flow through this network. So now some other properties which is available in standard version I've told you. This is packet trace. So when you enable this packet trace, you have to click on this and give the name. It will save in .csv format, and storage path is there. So these are some attributes which will create after the simulation. So TCP, wireless LAN, and some common attributes. So click on OK. Then you have to set the event trace. You set the name of the event trace. File type is same, file storage is same. These are the events performing in the network. This is for ARP, fast Ethernet, RIP, TCP, wireless LAN, and OSPF. So all the parameters would be there. So click on OK. Now dynamic metrics. If you want to create dynamic metrics, you have to just click on OK, and you can choose plot graph after simulation or during simulation. We will choose it for after simulation only, so that our simulation timing doesn't get affected. So click on OK. So we have set these parameters. Now we can run this simulation. Click on run. Change it to 20 seconds. Now you can set the packet animation also. If you want to record animation, you can click on record. You can play and record both. You can click on this. If you don't want to play and record, click on this. The simulation will run more faster. So we have to see the animation, so we'll click on record animation and click on OK. So while running the simulation, now we have chosen Wireshark, so it will get enabled during the simulation only. You will see the Wireshark running. It has started now, and now your real-time packet capturing will be started. There you can see TCP packets are being captured, and your simulation is still running. So it is capturing packets while running the simulation. It is capturing packet. Our simulation is also running. It is just completed now. Okay. Now our simulation has done. Now after running the simulation, you will get some performance metrics. I've told you it will give you the total network scenario about your network. Like in network metrics, you will get the information of simulation timing, packet transmitted, packet errored, packet collided, bytes transmitted, payload transmitted, overhead transmitted. Okay. So this is the overall information network. And in link metrics, you will get the information of the link. According to the link ID, it will show you the information about packet transmitted, errored packet, collided packet, and total throughput. Okay. Then in application metrics, you will get the overall network result, that is throughput, from source ID 1 to destination ID 6. Whatever packet have been transmitted, received, and payload transmitted, payload received, and throughput of total, and delays. We have enabled the dynamic metrics, so it will show you link throughput graph according to the link, like link 1, link 2, link 3, link 4, and link 5, that is wireless, and your application throughput, final throughput of the custom packet, then TCP congestion window application also. So it will show you according to the graph. And these are some other features: ARP table, ARP metrics, wireless LAN metrics, OSP metrics, and IP forwarding metrics, IP metrics. So now we'll go one by one through these features. So first of all, we have enabled the packet animation. So first of all, you see the packet animation, how the packets are moving. So we have enabled traffic from wireless node A to this one F 1 to 6. So we'll see the animation, how our packets are moving. So first of all, it will send some signals. Then when it will get the acknowledgement, it will send the custom type of packet. Now see, you can see this custom type of packet is being sent. Okay, you can change the animation speed from faster to slower, slower to faster. Okay, now we'll stop this and go to further analysis. Now we have set packet trace and event trace also. So we show you packet trace. When you open the packet trace, this ptr50.csv file would be open here. Here you can see the packet trace is open in Excel format. Now for better analysis, we just have to freeze this and we'll filter it. Now we'll show you one by one the packets. Like you want to analyze the packet 1, click on 1 and OK. So you can see our packet 1 is moved 4 times. There's a custom type packet we have set. It moved from 1 to 6 and 1 to 3 and 1 to 6, switch 3 router 4, node 1 6, router 4 access point, then 1 to 6 access point to node 6. So 1 to 6, how it has moved, you can see one by one. And the other information, whether it is being successful or not, IP addresses, details, all the detail about the packet you can see from here. So apart from this packet one, you can go for some more packets. Any number of packet you click on 5, it will give you the information of 5 only. Okay, so this is about packet trace. Now like this, there is a event trace. When you open it, that file name that we have set will open here and see you the information. So now the event, in event trace, you can see one by one the events performing in the network. Here also you can see these events are given. You can analyze these events one by one. Okay, according to their various parameter given: event type, event time, device type, device ID, interface, application, packet ID, protocols that has been implemented. These are the event IDs. So this for event analysis. Okay. All the data of the NetSim after the result can be exported into the MS Excel format. If you click on this, you can get the all data in the Excel format. So when you get the data in Excel format, you can create some more graphs by using these data. Now there is one more feature of go to NetSim Analytics. So when you save this experiment, and go to NetSim Analytics, here you can compare various metrics into one technology. Like if you select Internetworks and browse here the various metrics, we have chosen 4 metrics. Now if you click on these metrics parameters like simulation timing, packet transmitted, errored, collided, bytes transmitted. So these metrics have been created according to the various different parameters. So we can analyze those parameters by selecting these metrics over these parameters. Okay. So this we're comparing among these metrics file in the various network. So you can choose between these networks: LT, legacy network, BJP, MANET, WiMAX. Different networks can be compared from here. Okay. So now we have seen the GUI portion of this software. Now I will show you how you can edit the protocol in the software. So for editing those protocol, we have to go for NetSim installation directory where NetSim has been installed. See program files, NetSim standard. Here there is a bin folder. In this bin folder, all the related protocols given in NetSim are given here in their DLL format. So this NetSim accept the DLL format only. So if you want to change anything in the protocol or you want to implement your own protocol, you have to build this file into the DLL format only. So when you want to edit this DLL file, you have to go in SRC folder. In SRC, there is a simulation folder. So we have make a copy of this simulation so that our real DLL file would not get affected. So we just make a simulation copy of this file, and here you can see there is a link of this NetSim which open this Microsoft Visual Studio solution. So when we click on this NetSim link, it will open this Visual Studio which I have opened already. Here you can see all the protocols are listed here. Application, ARP, ATM, cellular, cognitive radio, DSR, Ethernet, all these protocols is given here. So when you open one of the protocol like DSR, you can see in the DSR.c file, this program is listed here, and we have changed something in the protocol. In NetSim's init function, we have given printf command for hello world. Okay, so when we build this .c file, it will create a DLL file that will be saved in this DLL folder of this simulation copy. So here you can see we have already built it and make one file libdsr.dll. So you have to copy this libdsr.dll into the bin folder. So we have already copied here. You can see libdsr.dll. This one is our created DLL, and this libdsr default.dll is our default, which we have renamed it to save it for future reference. So this is our DLL. Now when we use the DSR function, it will call our libdsr.dll and it will show you the editor result. So I'll show you one of the example of MANET which will use this function. Now we have created this 5 node, and we have set one CBR type of application over this node 1 to node 5. Okay, when we run the simulation, click on OK. So we have set the hello world in the program. Now we can see hello world is printed here, you know. So first of all, it will print our hello world that we have inserted in the program. Then if you put the enter, it will run the simulation further. So this is the process, just to show you that we can edit anything in the protocol and link it with NetSim GUI. So that is a small procedure to show you how we can edit this protocol. Okay. Now we have set some Wireshark feature also. So in Wireshark you can see these are real-time packet capturing. Some TCP packets are captured here, and you can see some graphs from here also. Like in statistics, you go for conversation, and if you click on TCP, you can see these graphs. Graph type, click on RTT, you will see round trip time graph, throughput graph, time sequence graph, window scaling graph, and this is time sequence TCP trace. So these graph can be shown in NetSim statistics, Wireshark. Then you can see IO graphs, some IO graphs. Here if you are to click TCP, then ICMP, and let's click on IPv4. There. We just show these two only. Click on point 1 and 10. So here you can see these graph 1 and graph 2 for TCP and ICMP. So this graph can be shown here. So this is the features of Wireshark. You can explore it more and see the various features of Wireshark. So this one is the overall description of this NetSim. Some more, one more thing we can see, like we have done it in simulation, we can go in the programming. So some of the set of programs have been set for ARP, cryptography, distance vector routing. So like in cryptography, you want to see the substitution type, click on this. So we have set of sample programs inbuilt here. So when we run the simple sample program for cryptography encryption, you have to set the plain text, then you have set the key text, and when we run, it will show you the ciphertext. Okay. Now you have got the ciphertext from plain text. If you click on this decryption, you will get from ciphertext to your original plain text. So this is the inbuilt program written in the NetSim only. If you want to use your codes, there is the option of user. If you click on user, it will prompt you to get exe file or zar file, so that you have to create it in this Visual Studio. You can create those files and link it here. So when you use it user, it will ask you executable file, zar file. Okay. So if you want to see these codes, you can click on interface source code. And it will open in Visual Studio. Here you can see the encryption program. This is the programming that has run there. If you want to change something, you can change here. Okay, you can see this concept, algorithm, pseudocodes, and flowchart. If you click on this, you will get the information about this program. Concept, algorithm, flowchart, all this information. So likewise, you can use cryptography, DVR, error correcting code, detection code, framing sequence, leaking bucket algorithm. All these are given. Shortest path. Okay, I'll show you for shortest path. You can set it for link state or floats, number of routers involved. If you click on this, it will ask you for a distance. If you click on this, it will ask you for distance here also. Okay. Now you have to set the source router like 1 or 3. So when you run this, it will show you the shortest path involved. So here you can see the 1, 2, 3 is the shortest path. So now we have done with our presentation. Now if you have any query, you can ask us through your mic, or you can write your queries also in the text box. Hello. 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 Do you have any query, sir?
Hello.
Hello. Vivek sir, do you have any query?
No, sir.
Okay, okay. Yeah, Akshay sir, for installing the NetSim, you have to purchase it, and provide you the training also, on-campus training, how to use it, and give some practice on this. You find it good for your use in your research or in lab experiments? If you have any query, you can ask me.
Verification खाली जाना है.
Any other query? If you have any query, you can ask me this time, or you can mail me also. This is my email ID. I'm just writing in the text box. You can see there.
No, sir.
This is my number. You can call me on this number. Hello. Do you have any query? Okay. Okay, ma'am, it is very much different from its open source, because in open source you have to create all these features. For if you design a network, you have to create the programming for nodes and the links and everything you have to write in program. So it will save you a lot of time by giving some GUI interface. So you can design it in GUI, and also if you want to edit some protocol, you can go to the Visual Studio and edit those protocol. So that's why these commercial softwares are very much useful, because it will save you a lot of time by giving a lot of emphasis not on the programming but on the technology. So that is why it is much more different from those open source softwares. Anything else, ma'am? Are you using such softwares, Sona, ma'am? ओपन भी नहीं हो रहा है ना। Okay, then I'll end this presentation for now. Thank you very much for attending.